Hello students, welcome to the new session where we will be discussing regarding polynomials, and before going deep in the discussion, we'll take a short recap what we have done in our previous videos. So in our previous videos, we already learned about the definition of a polynomial. To revise with what is definition of a polynomial, polynomial is also a type of algebraic expression which has the degree as a whole number, and the basic concept which we learned is the polynomial wasn't single variable. So what is single variable, double variable and more than two variables? So like if we have an expression like x square plus x plus 2, so this has only one variable, that is x, so this is in one variable, whereas x square plus y square, this is an example of two variable. Now when we have x square plus y square plus z square minus 3xyz or plus 3xyz, we say that this given expression is a polynomial which is in three different variables. But even in my last previous video also I have explained that we are going to discuss mostly for the single variable polynomials. Then we have learnt about the types of variable, where we have discussed about one term, two term, three term and four terms variables, and we classified them as types of polynomial. Now variable, what is variable? Variable stands for a value which keeps on varying. We can allot different values and it will change the answer. Terms, each independent which we are using, like x square, x and 2, these are the three terms. Here we have two terms. Here we have 1, 2, 3 and 4 terms. Here what is constant? Constant, in this example we have 2 as a constant, which is not having any variable, which you can see that it is not having a variable. But if you observe, even this is 2, this is 1 and here x has a degree of 0. So we also noticed that the power is getting reduced, and the same was explained in the standard form also. Then constant over, what is the coefficient? Coefficient is a numerical value including the sign which is along with the variable we are talking about, and the answer keeps on changing. Like if here we talk of the variable coefficient of x square, then it comes as 1. Coefficient of x, coincidentally it is 1. But here if we talk of coefficient of x, y and z, so if we talk of coefficient of x, the coefficient of x is 3yz, the coefficient of y is 3xz, the coefficient of z is 3xy. Clear? So it depends on the question for which particular term the coefficient is asked. Then standard form is a(n) to the power x, a0 to the power xn plus a1 xn minus 1 and this continues. Now what is 0 of a polynomial? We have seen in our last video where I have explained that just when a polynomial is given, if px is a polynomial, any polynomial, it could be a monomial or a lengthy polynomial, then for a particular value p1 is nothing but simply substituting the value. So we'll be substituting the value p1, and that is equal to 1 square plus 1 minus 2 will give you 1 plus 1 minus 2, and 2 minus 2 is 0. Clear? Now what will be the value of p power minus 1? It will be minus 1 square minus 1 plus 1 multiplied by minus 1 minus 2 will be 1 minus 1 minus 2, and this is 1 minus 3 minus 2. So what I was talking about is, if px is a polynomial, then finding the value of p1 is just substituting the value as 1 for x square plus x minus 2, and similarly for p minus 1 is to substitute the value of x as minus 1 and get the value. Now why we are doing so? There is a purpose for this. Now the first immediate purpose is when for a value where we are substituting x, p of 1 means value of x is 1. We are getting a value 0, and this is I am explaining you how to find p of a given value. Clear? Now when the value, I can show you two different values, 1 and -1. With -1 you are getting it as -2, whereas with the -1, -2 and with the value p as 1 you are getting it as 0. So when you are substituting the values for a given equation for variables, you are getting somewhere 0, sometimes you are getting some value. Now when you are getting some value, this is known as the remainder for that polynomial, and this is known as 0 of polynomial. So with the help of example, the two concepts are clear that for a particular value, on substituting in the equation, when we get answer as 0, that particular value will be called as 0 of the polynomial, whereas when you substitute the p of -1, what will be p of 2? P of 2 will be 2 square plus 2. That is 2 square is 4. 4 plus 2 is 6. 6 minus 2 is 4. Clear? So, we have seen that how we will get a remainder and how we are going to get 0 of a polynomial. Now we will be moving for a concept where we will be talking about the remainder theorem. Now what is remainder theorem? Now when we recall that if we divide 15 by 6, so what we get? See, this is 15, this is 6. We get it as 2s are 12 and 3 as a remainder. So how do we used to represent it? We used to represent it as dividend is equals to divisor into quotient plus a remainder. That is 15 is equals to 6 into 2 plus 3, which was 12 plus 3, and we used to get it as 15. So 15 is equals to 15. If we take the second example as 12 and 6, so immediately by 2 times you are getting it as 0. So how did you represent this? This was represented as 12 is equals to 6 into 2 plus remainder is 0. 12 is equal to 12. So this was exactly what we have seen in our previous slide, where we had shown that p of 1 is 0 and p of -1 was -2. So the same concept is applied to the polynomial, where we can see that if, now we will take two examples to be seen. They are like if a polynomial px cube plus x square plus x, the entire thing is divisible by x. So if it is a single number, what we will do, we will be dividing it each term by x. So the answer here is 2 into x cube minus 1 plus x square minus 1 plus x1 minus 1. So this will be 2x square plus x power 1 plus x power 0 is 2x square plus x plus 1. Clear? Now when we take the second example, where 3x square plus x minus 1 is divisible by x plus 1. So we remember how to divide it. Now we need 3x here, x square, and x we have, so we will be multiplying this by 3x. So x into 3x is 3x square, then 1 plus this is plus 3x. We will immediately change the sign here. This will be cancelled, and here we will have minus 2x minus 2. Now putting minus as the sign and multiplying it by 2, we will get the value as 2x minus 2x and minus 2. Again changing the sign for division, that is, we will be getting this as cancelled, and this is plus 2 and minus 1 it is. So we will be getting it as plus 1. Clear? Now how to represent this equation in the form which we know. So 3x square is nothing but px. Clear? Let this be gx. Now what we are seeing is, we are clearly seeing that the degree of px is 2 and the degree of gx is 1. So the first thing is, the degree of px must be greater than degree of gx, and gx should not be equal to 0. If such is the case, we get px is equal to gx into qx plus rx, where gx is x plus 1, qx is 3x minus 2 and rx is 1. Clear? Now, we have seen that we have divided it properly. Now, if we substitute the value here, p, see, this is x plus 1. The x plus 1, so whenever we have x plus 1, we will be taking the value for polynomial as minus 1. Clear? This is p of minus 1 when you substitute in the equation. This is minus 1 whole square plus minus 1 minus 1. That means this will become 3 and this is minus 1 minus 1 is 3 minus 2. Again you are getting it as 1. So instead of dividing it actually and finding the remainder, we can easily substitute the reverse value of this. If it is x minus 1, we will be substituting p of x as 1. Clear? And why it is so? Like if it is x plus 1, we expect that if this is dividing this one, so the remainder should be 0. Now if it is exactly dividing, then you will have x as minus 1. So hope the concept is clear. Now we'll take few cases where we will be checking few more variables. We'll see one more example where we will be dividing the polynomial, and in shortcut method also how to find the remainder. So if we say that this is dividing, gx is dividing px properly, in that case x is equals to x minus 1 is equal to 0, x is equal to 1. Clear? What we will be doing is, we will be in this side, we will be substituting the value as px square minus 4x cube minus 3x minus 1. So this is p of x, we are putting it as p of 1. So this becomes 3 into 1 square minus 4, 1, this is power 4. So we are getting it as 4 and 1 cube minus 3 into 1 minus 1. So 1 power 4 is 1 multiplied by 3 is 3 minus 4 minus 3 and minus 1. So if we see, this is becoming 3 minus 4 plus 3 7, 7 plus 1 8. The answer is coming as minus 5. Now which we have done in a very few seconds. Let's perform the proper division and see whether we are getting as minus 5 or not. So when we are dividing this equation, we want 3x power 4. So x minus 1 divided by 3x power 4 minus 4x cube minus 3x minus 1. So when you are practically dividing it, you will be taking it as 3x cube. This will become 3x power 4 minus 3x cube. Change the sign. This is plus, this will be changed as minus. Now we will be cancelling this and we will have here as x cube minus 3x minus 1. To get x cube, we will be putting it as minus sign, so minus x square. Now this is x minus x cube minus, yes, that's x, minus into minus is plus, plus x square. Now when you change the sign, this becomes minus. We are cancelled x square, we don't have any value, but we will be keeping it as minus x square minus 3x minus 1. Now we need x square. So we will be keeping it as minus x, and this will be minus x square plus x. So this will come when after changing the sign. This will be plus, this will be minus. This is 4x minus 1. This gets cancelled. Now 4x means you are writing it as minus. So minus 4. Then this is 4x plus 4. Again changing the sign. This plus will be changed as this minus will be changed as plus. So this is cancelled. Here it is minus and minus 5. So even after doing the long division method for polynomial or substituting the value here, we are getting it as the same value. We'll check for one more example where if p of x is x cube x, that is x cube plus 1, and g of x, the second equation with which we will be dividing, is x plus 1. Clear? Again, if it is x plus 1, in shortcut method, we will be substituting as p of minus 1. So, p of minus 1 is x cube, that is 1 minus 1 cube plus 1. So, minus 1 cube is minus 1 and plus 1 will give you 0. So, we will get a remainder 0 when we are dividing this exactly. So, x square plus 1, x plus 1, where x square will be coming here and we will be writing it as x cube plus x square. This is minus. This plus will change to minus. This gets cancelled. Here we have minus x square plus 1. Now to make it as x square minus x, you will get it as minus x square plus into minus minus x. Change the sign here also. This gets cancelled. Plus x plus 1. You will be multiplying this by plus 1. So this is x plus 1 minus and minus. Changing the signs and cancelling, you will be getting it as 0. So isn't it in the more than 3 examples we have seen where the actual division process is as same as substituting the value for the variable and getting the remainder. So based on these examples, we can conclude the remainder theorem. What is remainder theorem? The remainder theorem says that if p of x is a polynomial and it is divided by gx, definitely the degree of gx should be less than px, and this will be multiplied by qx, the quotient, and rx as the remainder. Clear? And r as the remainder. So we'll be stating it in the statement form. In the statement form it is, let px be any polynomial of degree greater than or equal to 1 and let a be any real number. Then if p of x is divided by x minus a, then the remainder is p of a. Clear? That is px is equals to x minus a. Some quotient will come and some remainder will be there. Now if x minus a is exactly dividing and the remainder becomes 0, as you can see the degree is 1 and here the degree must be less than that. So if the degree becomes 0, this has to be 0. Why 0? Because a minus a is 0. So we will be substituting the value of p of a. P of a, when we are substituting, this becomes x will be changed as a minus a into qx plus r. That means this is nothing but 0. 0 multiplied by any polynomial will give you 0. 0 plus r is nothing but r. So that exactly we are saying that the remainder is p of a. So whatever when substituting a you are getting, the same is the remainder which we have seen already in our previous examples. Now without actually dividing, we will check the remainder and for a given polynomial. Also verify the statement. The equation could be x cube plus 3x square plus 5x plus 6 This is your Px. Clear? And this is your Px, and 2x plus 4 is to be examined whether x plus 2 is a factor or not. For such case, you will be, see, as I told you, x plus 2, if it is a factor, it has to be equal to 0. If it is 0, in that case, x plus 2 is equals to 0, x has to be minus 2. So what value we will be substituting? We will be substituting here as p of minus 2. P of minus 2 is minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6 will give you here as minus 8 plus 3 and 2 square is 4. This becomes 12. This is minus 10 and this is 6. So minus 8 minus 10 is minus 18 and this becomes 18. You are getting it as 0. For 2x plus 4, 2 to be multiplied by minus 2 plus 4, this is minus 4 plus 4 is 0. Hence we can say that x plus 2 is a factor of this polynomial and it is also a factor of this polynomial. So isn't it how easy? Rather than going for a long division method, in shortcut method we can check and verify whether the question given satisfies the condition or not. So we'll take one more example. So the application of remainder theorem, where we are going to use the remainder theorem and find an unknown value given in the polynomial. Now find the value of k if x minus a is a factor of 4x cube minus 3x square minus 4x plus k. Now we are very clear with this concept that if x minus a is a factor, the remainder which we are going to get is 0. So as x minus a is a factor, we are going to write first p of x, that is x cube plus 3x square minus 4x plus k. And as x minus 1 is a factor, that means x minus 1 is equal to 0. X minus 1 is equals to 0, x is equals to 1. So p of 1 will be 4, 1 cube plus 3, 1 square minus 4, 1 plus k, which is coming as 4 plus 3 minus 4 plus k. Clear? Now we know that this 4 in plus 4 in minus 4 will be cancelled. We are left with 3 plus k. P of x that is given and x minus a is a factor. So this value has to be 0. Means the remainder part will be 0. Now we can, what we will do, we will be shifting the value, that is k is equal to minus 3. So when we substitute minus 3, the entire equation remainder will be 0. Let's check it. So 4, in this statement only we will be checking. 4 plus 3 minus 4 minus 3. So plus 3 minus 3 cancel, minus 4 cancel. We are going to get p of 1 is equals to 0 if k value is taken as minus 3. So remainder theorem is checked with examples and also the application we have seen. Let's move for the factor theorem. Now after remainder theorem we will be going through factor theorem. What is factor theorem? If p of x is a polynomial of degree n greater than or equal to 1 and a is a real number, in such a condition x minus a is a factor of px. X minus a is a factor of px if p of a is equals to 0. Means the condition it's specifying is x minus a is a factor only if when you substitute a instead of x in the given polynomial, and the remainder comes as 0. So for the verification of this, we have p of x is equals to x minus a into qx plus pa as x minus a is the factor. Clear? Now, what p of a should be 0. If p of a is 0, definitely p of a is 0. Here, see, it is 0. Now what we need to do is, instead of x, we are substituting the values as a. So a minus a is going to be 0. Whatever be the coefficient, if it is multiplied, whatever be the q value, if it is multiplied by 0, the resultant is going to be 0. Hence, we can say that x minus a is a factor. In the second case, the reverse condition. If p of a is equals to 0, p of a is equals to 0, if x minus a is a factor. Now what, recall from the remainder theorem? X minus a is a factor, you will get the remainder as 0. So remainder part is 0. Now substitute what we did in that, we substituted the value with equating it as 0 and reverse of that is x minus a is a factor. So you will be substituting the value as x value will be a. So a minus a is 0, 0 into something is again 0. So this is exactly what factor theorem says. Now we will be using this and to solve the polynomials by using splitting middle term, and we will see how this theorem is practically applied on working problems. Now we are applying factor theorem on this problem, and we will be using splitting middle term method, which we have already used in our previous classes. Now what was splitting middle term? For splitting middle term, see, if this is an equation ax square plus bx plus c, the first thing done was product of a and c was taken. Now product of a and c, whatever value you are getting, you just tried to find the factor of that and the combination of the factors in such a way that you got the value as b. So we will be checking here, 6 5s are, it's 30. Clear? We will be taking a factor where the addition or subtraction will be 30 and will need to, multiplication should be 30 and addition or subtraction has to be 17. So if we factorize 30, it's 2 15, clear, or 3 and 5. So either you can take the factor as 6 and 5, you can take it as 3 and 10, you can take it as 2 and 15. So all the factors will definitely give you what, 30 as the resultant. 6 5s are 30, 3 10s are 30, 2 and 15 also 30. We need to select such a pair which will give you 17 as sum. Now, if we write it as 6x square plus 15x, or we can take it as 2x plus 15x plus 5. See, product of this we are getting 30, addition we are getting it as 17. So when we take common from this, that is 3x taken as common, this becomes 3 2s are 6x plus 2 will be taken as common, 2x. So this is 2 3s are plus 1, and here 5 will be taken common. So this is 3x plus 1. The factor is 2x plus 5 and 3x plus 1. So these are the factors, clear, for the given equation 6x square plus 17x plus 5. Now what does the factor theorem says? Factor theorem says that this is going to be a factor for this only when p of a is equals to 0. Now if we want to find, see, when it can be 0, either this has to be 0, 0 multiplied by 3x plus 1, or 3x plus 1 could be 0 because 2x plus 5 into 0 will become 0, or both will be 0. Now let's check how it is practically working. See, if you take as 2x plus 5 is equal to 0. That means 2x is equals to minus 5 and x value will be minus 5 by 2. Clear? That means P of minus 5 by 2 should be 0 as per the factor theorem if this is a factor. Or else if 3x plus 1 is a factor, then it has to be equated to 0. 3x is equals to minus 1 and x value will be minus 1 by 3. In that case, P of minus 1 by 3 must be 0. If P of minus 5 by 2 is 0, we can say that 2x plus 5 is a factor. Or if P of minus 1 by 3 is equals to 0, we can say that this is a factor for this. Or else both could be P of minus 1 by 2 can also be a 0 for this polynomial, or minus 1 by 3 could also be a 0 of a polynomial. In other case, we will check for which particular number the remainder is going to be 0. Clear? Now, we will quickly check the values. If the value for this is P minus 5 by 2. So, we will be substituting here, that is 6 into minus 5 by 2 whole square plus 17 into minus 5 by 2 plus 5 will give you 6 into 25 by 4, which when cancels, this is 2, this is 3. Plus, this will become 17 into minus 5 is minus 85 by 2. Plus, this will become 10 by 2. Clear? Now, when you multiply this, this is 75 plus of minus is 85 plus 10 by 2 will be 85 minus 85 by 2. 0 by 2 is 0. Clear? So, we have seen that P of minus 5 by 2 is 0. As P of minus 5 by 2 is 0, we can say that 2x plus 5 is a factor. Now, quickly we will check for minus 1 by 3. If we check it for minus 1 by 3, P of minus 1 by 3, that is 6 into minus 1 by 3 whole square plus 17 into minus 1 by 3 plus 5 will give you 6 minus 6 by 9. This is 2 and this is 3 plus. Here it is 17, 1 minus 1 by 3. So this will become minus 17 by 3 and this is 5. So this is 2 by 3 minus 17 plus 15 by 3, which is 17 minus 17 by 3. 0 by 3 will result in as 0. So, as per the factor theorem, both the conditions are satisfied. This will be a factor when P of minus 5 by 2 is 0, so getting satisfied. 3 of x plus 1 is a factor if P of minus 1 by 3 is getting a remainder 0. Both the conditions we have seen the remainder is 0. So hence we can say that as per the factor theorem, 2x plus 5 and 3x plus 5 are factor for 6x square plus 17x plus 5. Quickly we'll check for one more polynomial. Now this time our polynomial will be x square minus 22x plus 120. So quickly again taking the product of a and c, it will come as, here it is 1. So 1 into 120 is definitely 120. Now when you find the product of when you find the factor of 120, easily to get the sum of product as 22. So we can take it as minus 12x and minus 10x. See, the product 12 into 10 is 120. And by finding the product, both the numbers are negative, you will get a positive value. So this is 120 and this is x square. X taken common, x minus 12, minus 10 taken common from this, x minus 12. So here quickly we can see that x minus 12 and x minus 10 are factor. If x minus 12 and x minus 10 are factor, what will be the value of P of A? P of A, as I have shown, x minus 12 will be equated to 0. Now x is to be substituted by plus 12. So P of 12 will be 12 square minus 22x, that is 22 into 12 plus 120. Now 12 square is 144 and this is 120. What is the product of 22 into 12? This is 44 and 12 is 164. So minus 164. Now when you add these two, 4 and 4, 22. This is 264. Clear? So when you add these two, you are waiting to get 264 minus 264 is equals to 0. Hence, x minus 12 is a factor. Now let's check P of 10. Now P of 10 is 10 square minus 22 into 10 plus 120. 10 square is 100 minus 220 plus 120 is again 220 minus 220 is equal to 0. So hence P of 12 is 0, P of 10 is 0. We can say that x minus 12 and x minus 10 are factor for given polynomial x square minus 22 plus 120. Now what happens if this example where you can use splitting term, it's very easy. Now for if the equation is given a bigger equation, now how can we check if the degree is more than 2? Now let's consider an example for a bit complicated one using splitting terms. Now x cube minus 23x square plus 142x minus 120. So if you see it very clearly, it's not so easy to factorize the problem, but we can try it in many of the ways. The first one would be by taking the first part as common, taking x out, and then this will become x outside, x square minus 23x plus 142 and factorizing it by 1 and taking 120 in the consideration. The next one is by this method where we are trying now is, see, from these two we can easily see that x square is common. So we have taken x square into x is remained, and this 23x square here is written as x cube minus x square minus 22x square plus 142x minus 120. See, this the splitting is done, but we cannot change the values, but we can readjust the values. So here 23 is written as x square minus 22x square, whereas 142x is written as 22x minus 22 and minus 22x. So this is, yeah. So what we can see here is we have taken x square into x minus 1 as common, minus 22x square has remained plus 142x minus 120. So the next step is we cannot do anything regarding this. Now we will be checking it here. So this has becomes x square and x square. We need 22x in the center. So 22x is balanced by adding 22x here plus 22x square, and by same way minus 120 is balanced by adding 120x here. Now here this is the addition work which we are doing. We are balancing the equation by adding the additive inverse of this and additive inverse of this. So we are not changing the value, we have just made it easier for the solution. From these two we have taken 22x common, x minus 1 as a factor, plus 120 from these two, again we are getting this one. Yeah. So what we can observe in this statement is x minus 1 is common term in all. So x minus 1 taken out, we have remained with x square here, x minus 1 taken as minus 22x and x minus 1 taken as 120. Just in the previous example, we have seen the factor of x square minus 22x plus 120 by splitting middle term were x minus 12 and x minus 10. So from these three, if the factor of this given polynomial px are found to be x minus 1, x minus 12 and x minus 10. If we have already seen that x minus 12 is a factor because when you substitute x by 12, you got the value to be 0. And when you have substituted 10, you got the value to be 0. If any one of the one is 0 among these three factors, the remaining product is going to be the 0, 1. So, but for your clarification, you can substitute the value by 1 and check whether you are getting P of x as 0, P of 1 as 0 or not, P of 12 0 and P of 10 0. Now quickly coming to the third method where we can easily identify the factors in rough figure are, see, whatever lengthy sentence it may be, Px may have a big polynomial with many variables and degrees. The only condition is it should be greater than 1. We need to see the constant term and the first form. So here the product is 120. What are the factors of 120? See, 1, 12 and 10. If you multiply these three together, you are going to get 120. See what we have got: x minus 1, x minus 12 and x minus 10. So, if we are not following this method, we can guess that 120 may have factor as P1, P12 and P10. And we can verify the values by just simply putting P1, P12 and P10. If the remainder comes as 0, we can declare that x minus 1 is a factor, x minus 12 is a factor and x minus 10 is a factor. Clear? So, with this we will be ending our session for today. We will be meeting soon with identity applications. Please go through the algebraic expressions and formulas. Thanks a lot.